Yes, today's class we will learn what are the different numbering systems and we learn what are the Python literals. So first we will start with the numbering system. So in programming or in computers, generally we will see three types of numbering system. So first one, decimal numbering system. Second one, binary numbering system. Third one, octal numbering system. And fourth one, hexadecimal numbering system. So let us go for these all in detail. So here, decimal. Deci means 10. So means under decimal numbering system, we have 10 digits. So that the base of this decimal numbering system is 10. So let us know what are the digits comes under this one. So the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these comes under the digits. So here, when we are learning mathematics, we follow decimal numbering system only. And every decimal numbering system having its own unique name. Okay. So similarly, unique name is nothing but, for example, I have written 45. So its name is 45. Are you clear? So like that, we have specific name for every combinational digit. So next we will go for binary numbering system, and its base is 2, and it contain only 2 digits, so that are 0, 1. Next, we have octal numbering system. Its base is 8, and the digits comes under this are 0, 1, 2, 3, 4, 5, 6, 7, 8. So 8 never comes under this one. We have digits up to 7 only. Next, hexadeci. Hexa means 6, deca means 10. So total, its base is 16. And we are writing the digits. The digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Up to here, 10 digits are completed. Next, remaining 6 digits can be represented with alphabets, English alphabets. So A, B, C, D, E, F. So these 6 digits representing the 10, 11, 12, 13, 14, 15. So when octal numbering system, number starts from 0 and closed at 7. When it is decimal, it started at 0, completed at a 9. Similarly, when it is hexadecimal, which starts with 0 and complete it by 15. So 15 can be represented using one alphabet, that is F. Here you have to raise question. Sir, definitely we need to write in lowercase. No, you can go for uppercase also, which is accepted. So here, now we have to represent these things in Python program. So how can I represent decimal number? How can I represent binary number? How can I represent octal number? How can I represent hexadecimal number? So in Python, so we follow syntax. The syntax conveys to the compiler that we are writing the numbering, that numbering belonging to any one of the category of this one. So how can we represent? So for example, we will start with the binary number. So here the binary representation. So generally this binary number contain zeros and ones only. We will go for this combination. 0, 1, 1, 0, 1, 1, 1, like that I have written. But how can I represent this number is a binary number to my Python program? So to represent that prefix, I am going to write 0b. So this 0b conveys to your Python compiler that the number which I have written it here belonging to the binary number. So here you have to raise another question. Sir, can I write only lowercase b? No, you can write uppercase b also, which is giving the same meaning to your Python compiler. So here this lowercase b, uppercase b, you can write anything. So coming to the octal representation, okay, before this octal number, we need to write 0 O as a prefix. This prefix conveys to your Python compiler that the number which I am going to write it here, which is belonging to the octal number. So 1, 7, 3, 2, 8, like that you can write. 8 is the invalid number. If I write it here, immediately your Python compiler will give you an error. I will show that one also. So I can write uppercase letter, I can write lowercase alphabet. Next one, hexadecimal numbering system. So while writing hexadecimal, I am going to give the prefix as 0, capital X, or 0, lowercase x. You can write anything followed by the digits you can write. So 1A, 2, F, 3, B, like that you can write anything. 1A, 2, F, 3, B, like that we have to write for hexadecimal numbering system. Coming to the decimal numbering system, we never write any prefix before number because generally Python program consider decimal number only, and even we go for mathematics, we use direct decimal numbering system only. So Python has designed, not only Python, every programming language has designed to hold the numeric data in decimal numbering system only. So we never write any prefix, and we can go for any combination of this one. So 1, 2, 3. So this is the combination of a decimal numbering system, and we have particular name to this one. This is the 123. So this is the way we have to use. Now let us go for one simple example how to use them in the Python program. So here we will test this everything. So x is a one of the variable. If you give 10, which consider it as a 10 number, and if I give 0b 10, so it is not 10 because 1 comma 0 which is considered as a binary numbering system. At that time, this x is considered this number as a 2. Okay. Next, when I go for x equal to 0 or 1, 0. So in this case, this one never consider like a 2 and never consider like a 10. It consider x as a 8. Why I will tell you. Next, if I go for x equal to 0, x 1, 0. In this case, this x is consider this number as a 16. Sir, how did you say this all? I will tell you. I will give you one table which contain 20 numbers, and we will check whether they are representing same thing or not. So now I am writing numbers in all numbering system from, okay, these all are the numbers from 0 to 20, and I have written this every number in all numbering system. So just now I said, while writing this binary number prefix, we need to write 0b. So you can write lowercase b or you can write uppercase b. When it is octal number, we have to write 0o either in lowercase or uppercase. And while writing hexadecimal, we will write 0x, either it is in lowercase or uppercase. Now we understand how this will be work. So for example, I have a number. So for example, x is a one of the variable and we will test this 14. So I have given this value 14. So did I write anything prefix of this number? I did not write. So here, your Python compiler can understand this number in the decimal representation and x can store value which is 50. Memory is created and this memory is going to be referred using x variable and which holds 14 value. Similarly, the same 14 I want to assign to another variable which is y, but not in decimal representation. I got the result in binary representation. So how can I write? This is the binary number you get from system resources or end user has given like this. So now I want to convert and I want to know what is the value of this one in decimal representation system. So how can I assign this one? This is binary number. So I should go for 0b prefix. 0b I am writing and followed by 110 I am writing. 1110. So this number is also 14. Next, I want to assign octal value. This octal value 14 in decimal 14 value, but in octal value we will write this one with 16. So z equal to 16. When I write like this, it acts like a decimal number. So to make this number as a octal number, I am writing 0o as a prefix to this one. So this is binary, this is octal. And I am going to take another variable where I want to assign the hexadecimal value, which should be equivalent to 14. So what is the number I need to write? Lowercase e. I will write lowercase e, and to convey to your Python compiler that this e is belonging to the hexadecimal, I should write ox as a prefix. Ox space e. So this is the way we will write. And when I check these all values, so when I print x value and y value, z value, a value, this all will print a result as 14. Now let us check whether these all values are giving 14 or not. I am testing only one value which is 14. So to check that one, I am opening Tony. Right. So I am assigning a value. So x equal to 40 and y equal to 0b 1110. Next z equal to 0 16 I have written and a equal to 0x e I have written. Next I am going to test these all variable values, print y, print z and print a. So when I check this one, I can see this all results as 14. So this is the way we will assign values to these different numbering system values we can assign to the variable and you can work with this one. So when I am saying this one, immediately you have to raise one question. What is that? Sir, always these values are returning in the decimal numbering system only. but I don't want to get the result in decimal representation. I want to print these values. I want to see the result in binary number, or I want to see the result in octal number. So how can I check? It is also possible through the Python program, so that we have to learn three different functions. So that are numbering conversion functions. So number conversion functions. So in Python, we have three number conversion functions. So first one, bin function. What does this bin function doing? It will convert octal value, decimal value, and hexadecimal value to binary number. Second one, OCT oct function, which convert hexadecimal value, decimal value, binary value to octal representation. Third one, hex function, which convert binary value, octal value, decimal value to hexadecimal type. So let us check these all in detail. So I am going to use one of the example from this. So here I will go for this number and will test this one. So I will go for this 20 and will convert one to another type. So here, first I am going to use bin function. Bin function. So I will give octal value. Next, for bin function, I will give hexadecimal value. For bin function, I am giving decimal value, and I want to get the result in binary representation. So I will write examples to this all. Binary. So what is the octal representation of this 10101000? So octal value, this is the octal value. I am giving 24 and I will get the result. Can I write 24 directly? No. So this is octal number, so that I should give prefix as 0O. So 0O and followed by 24 I am giving. So what is the result I get? 10100 prefix, it will be appear 0B. Next one, bin 14 number. 14 I am giving, which is hexadecimal representation 14, and when it is hexadecimal 0x I will write, and I can see the result. The same result will be appear 101 000, not 000, only 00. Next one. So for binary, I am giving 20. So this is decimal representation. I need not to write any prefix to this one. When I see, I can get result as like this. So let us check whether everything will be converted to binary number or not. So I will go for my Python platform and I am going to test it now. So here directly I am clicking in the shell prompt itself. So bin 0O 24 I am giving. And when I hit enter, I can see 10100. Similarly, bin 0x14 I am giving. So I can get the same result. Bin decimal number 20 directly I am giving, I can see result in the binary value. So these two are same numbers. So here we have tested binary. Similarly, we can do octal and hexadecimal. Next, I am writing these things, you can practice from your end. Next one. Another function, we will go for octo function. Now we will go for another function, which is octo function. So what does this octo do? It will convert remaining all data numbering system values to octal numbering system. So I am giving binary value as a input. For this octal number, I will give decimal number. For this octal number, I will give hexadecimal value, and I will check what is the result I will get when I use this one. So octal, for this octal, I will give binary value. For this octal, I will give decimal value. For this octal, I will give hexadecimal value. So binary value, I will go for the same number only, 0B, 10100. Next decimal value, this is decimal 20 I am giving input, and hexadecimal value 0x14, and these all results we will get only one number. Can you expect what it is? 0024. This is the result I can get when I use this one. You have to test this one. Next one. I want to know hexadecimal values of given numbering. So I am giving binary value as an input. For this hexadecimal, I will give octal value. For the same hexadecimal, I am giving decimal value. And I will check its respective values. So hexadecimal, for this I am giving binary value 0B10100. Next, for a hexadecimal, I am giving octal value 0024. And for hexadecimal, I am giving decimal representation 20. And this all will return the same result, which is 0x14. Okay, so you have to test these things, and we'll check whether they are returning the same results or not. I have shown this all, and just we are converting this remaining data type to octal at here, this remaining numbering systems to hexadecimal at here. Next. So once you understand these things, we can go for second part from today's lecture, which is Python literals. So Python literals. Now, let us understand what is literal. Literal is nothing but it is a value. Literal is nothing but it is a value we are assigning to a variables. So how do we do this one? X is a variable and I have assigned 10. So this 10 is a value. Tell me which type of value it is? Decimal value. Okay, this decimal value I am assigning to a X variable. So this is one literal. Which literal? Decimal literal. So coming to here, we learn different type of data. So integer type of data we have seen. We have seen float type of data, and we learn string type of data. We learn complex type of data, and we learn Boolean type of data. So these are the different things, different basic data types were present in Python. We have none also, but there is no only one value we need to be assigned. Now, so here, when you have integer data type, we have respect to literals. So integer literal and the float literal, and the next one string literal, and the complex literal, and Boolean literal. Because when I am writing integer, so integer has its own value that is called literal. So let us understand these things in detail. So here, when I go for integer literal, so the value of integer can be given to a Python variable in 4 different ways. I can give 4 ways. So first one, you can give the value in binary representation. You can give this value in octal representation. We can give this integer value in hexadecimal representation, and we can give this value in binary decimal representation. These are 4 types I can give integer number to a Python variable. So example, just now I said whether we are assigning or not. So x equal to 0b111 I have written. This is for binary value. X equal to 0o13 I have written. X equal to 0x a I have written. X equal to 24 directly I have given. So these all are the different numbering systems I have used to assign integer type of data to this variable. So these are said to be the integer literals. So coming to the float literals, we can give float values in 2 representations. Okay. So here we can't assign float values in binary, octal, hexadecimal, and decimal representation. We definitely give these float values in decimal representation only. Decimal representation. So if I give octal representation of this float value, then immediately your Python will give an error. So I am going to test x equal to binary representation 0b111.111. If I give like this, immediately your compiler will give an error. It is invalid type. So definitely we should give float values in decimal representation. But here, this decimal value, you can write in 2 ways. One is numeric representation, and second one is exponential representation. So example, x equal to 5.3. This is one representation. Next, another way, you can give this one like x equal to 5.3 e to the power of 4. This is also valid. So in Python, this e indicates 10, e value equal to 10, which means x equal to 5.3. So 5.3 into 10 to the power of 4. So 10 to the power of 4 is nothing but 1 followed by 4 zeros, which is 10,000. 10,000 multiplied with 53. So 10,000 into 5, 50,000, and into 3, 53,000. So this is the result you will get when I perform this operation. And followed by dot zeros will be appear. These are the 2 ways we try to test whether it is working in Python or not. So here, this integer literals, just now I have given it here. Next one, we will test for the float values. So x equal to 0b111.000 I am testing. So when I go for this one, is it valid? Invalid. It is invalid. So when I run this one, it has given invalid syntax. So means while giving floating value, you never allow to write dot followed by this representation. So next one, we will go for these two representations, x equal to 5.3. Yes, I got the result. And when I print x value, it has printed x as 5.3. Next, x equal to 5.3 to the power of 4. I have written just e followed by 4. And when I print x value, I can see 53,000. So I hope it is clear to you. Next one, we will go for string literals. So already we learned how can we give string literal. So x equal to double quote. You can write the data in the double quote followed by any number. So I am writing Python. So which is also considered like a string literal. And if you give any data numeric and which is enclosed by double quote, which is also accept like a string literal. So coming to here, we can write a string literal two ways. One is using double quote, and second one single quote. So these are the two methods available in Python. Next one, complex literal. So here we have to understand this one carefully. So when I go for complex value, which has two parts. One is the real part, real number, plus followed by imaginary part, imaginary number, followed by j, we will write. So coming to here, when I go for this real value, so when it is complex number, this real type can be integer number and this real type can be, it is a float value. Next, coming to the imaginary value, this imaginary value can be integer number and this imaginary value can be a float number. So let us check whether these four combinations were present or not. So here, x is a variable and I am giving 10 plus 10j. So both imaginary and the real value both are integer type. So x equal to 10.5 plus 20j. So real is integer and imaginary is, real is float, integer is imaginary. Next, x equal to 10.5 plus 10.5. Now both are float values. Next, x equal to 10 plus 10.5. So these are the four ways I can write. So integer type combination is possible in complex representation, float type of values for real and imaginary in complex representation. So now let us understand how this will be work. So when the value is integer type, so I will go for real number. Next, I will go for imaginary part. So when your number, real number is a integer type, then you can go for these four type of literals. Integer literal you can give, integer literal you can give, float, octal, hexadecimal, binary, and decimal representation. These four out of four types you can give. Next one, if it is float value, you can go for this representation, this representation. These all can be give input to your complex number for the real part. So let us check whether it is working or not. So here, complex number I am creating. So which is 10 Just you concentrate at the real part only. We will understand the imaginary part later. So 10 plus nj. So this is decimal representation which is working. X equal to 0 O 10 plus nj. So which is also working when I print X value, which is printed 8 plus EJ. Because in octal representation, 10 represent 8 in decimal. Next one. X equal to 0x A plus nj. So A, I am giving in hexadecimal representation, A equal to 10 in decimal value. So I can see X value as 10 plus 10j. Next one, X equal to 0b 10, which is 2 plus 10j. I am writing. When I check this one, it has executed successfully. And when I run this one, I can see 2 plus 10j. So when real value is integer type, I can give any representation. So I can go for this 4 kind of literal. So similarly, when I go for float values, I can go for these two representation for the real number. So 5.5 plus 2j, which is working. Next, x equal to 5.5 E2. E2 is nothing but E square. E square is nothing but 100. 100 into 5.5, 550 plus 2j, which is also working fine. When I see that 550 plus 2j, it has printed. So then the value is real under complex. So when you take integer, I can go for these 4 letters. When it is float, I can go for these two representation. Next, when it is imaginary, we'll go for imaginary. When it is imaginary, let us understand what happens. So x equal to 10. I am fixing real value. Just understand how many ways I can give the imaginary value. Okay, which means I have given this value in the decimal representation, which is working fine. X equal to 10 plus 0b 1010j. Now you understand this one carefully. What happens when you try to give the imaginary value in binary representation, which conveys you the invalid binary literal. Next, similarly, let you imagine whether it is working or not. 0 O 1 2 J I am giving. Is it support? It is also does not support. Next, check that. So it is also invalid octal literal. So x equal to 10 plus 0 x a j I am writing, which is also invalid. So now I hope it is clear. When in complex number, when I go for integer part, I can give any integer literal. When I go for real part with the float value, I can go for these two types. But when I go for imaginary type, I should give integer number in decimal representation only. I can't give binary, octal, hexadecimal representation. Now, similarly, we will test for float type of values also. X equal to 10 plus 4.3 j. This will work, and already we have tested x equal to 5.3 10 plus 5.3 E2 j I am writing. So here now you imagine one time. When I am writing hexadecimal value followed by j, when I write like this, it has appeared black color. This one printed in some other color. So here, which by typing this one, we can understand this is invalid. But if you observe this one, these both will be printed in same color. Can you expect what is happening? So when I hit enter, which accepted. So when I check this x value, E2 is nothing but 100, 10 square 100, 5.3 into 100, 5300. And when I print, 530, and it has printed 530. This is the way we can give. So now we will summarize this one. So when it is, this real part is integer, when real is integer, I can give decimal, hexadecimal, octal, and binary. Next, when real number is float, I can give general float value and exponential value. These all possible for the real. But when I go for the imaginary part, so imaginary, and when it is integer, I should go for decimal only. When I give another format, it has given an error. And imaginary part, when it is float, I can give both ways, like a float value or exponential value. These both can be supported. And when I go for Boolean literal, there is only two values, which is true and another is false. So x equal to true and x equal to false. Other than this, we do not have any other type. I hope it is clear to you how Python literals are there. Means how many ways we can assign value when it is integer type, when it is float type, when it is string type, when it is complex type, when it is Boolean type. Okay, so we'll meet again in the next class.